So we're going to start off with our warm-up. And our warm-up says, the graph shows the terminal side of an angle with measured theta and its supplement 180 minus theta on the unit circle. So before I even read part A, I'm just going to show you this picture over here. The angle theta is the blue angle, and the orangish reddish angle is the supplemental angle. And you can see the way they're set up right now, the blue angle is 45 and the orange one is 135. If you added those together, you would get 180. And we have this slider down here, and I'm just going to show you, we can slide it around. Let's say if I leave it right there. The blue angle now, theta, is 69, and the supplement is 111. And if you added those two together, you still get 180. And I can just keep moving this around, and you should see that, anywhere I put it, the original angle, the blue one, and the supplement, the orange one, are always going to add up to 180. I could leave it there at 178.2. So that's how this slider thing works here. So part A says, how are the coordinates of the intersection of the terminal side of an angle with measured theta and the unit circle related to the sine and cosine of the angle? So there's a whole lot in that statement. So we're going to try to break down the statement so we can really understand what it means before we try to answer it. So it says, how are the coordinates? So you guys know coordinates, x, y coordinates. You can even see on the picture here that they have x, y in blue, and they have question mark for the supplemental angle. So we understand what coordinates are. They want to know the coordinates of the intersection. So two things are intersecting. So they're intersecting the terminal side of the angle. So that's the blue thing. That's the terminal side. And the unit circle. So the blue side and the unit circle intersect at point x comma y, and the supplement angle and the unit circle intersect at point question mark. So we're going to figure out what those question marks are. So we need to figure out how those things are related to the sine and cosine of the angle. So what I'm actually going to do now is jump over to my other screen, and I'm going to be able to write on the screen. So give me a second. I will pull that up. Okay, so there we go. Okay, so what we're going to do, I'm going to do this in blue real quick just so we can see the same color. If I take this thing and I draw a line straight down so that I formed a triangle now, I'm going to change this to a different color just so that you can fix out a little bit better. If this is our angle theta in here, for this blue triangle, the side that's opposite is over here. Notice that this distance from here up to here is a y distance. And this side down here is our adjacent side. And this side of the triangle is an x distance. So we know from earlier, the first lesson, that the sine of some angle is equal to the opposite side over the hypotenuse. And on our triangle right now, the opposite side is y. And because this is a triangle that's inside the unit circle, this radius right here, this hypotenuse length, is 1. So y divided by 1 is just y. And similarly, if we do the cosine of our angle, that's the adjacent side over the hypotenuse. and our adjacent side is x over the hypotenuse, and that's just going to be x. So that relationship sets us up really well to be able to answer part A of our question. So I'm going to jump back over to my screen where I can write on. So now I'm back over here, and I need to talk about how these coordinate points, x, y, are related to the sine and cosine of the angle. So I'm going to say the sine of, let's see where I can pull up theta from. There we go. Sine of theta is equal to y over r. But since r equals 1, I know that sine, let's see if I can copy this. Sine of theta is really just equal to y. Similarly, cosine of theta is equal to x. And these relationships that we just put in here are hugely important to this concept of trigonometry and the unit circle and solving for different measurements inside of angles and in the unit circle. Part B says, what do you notice about theta and the measure of the acute angle formed by the terminal side of the supplemental angle and the x-axis? So this might be kind of tricky. I'm going to jump back over to my other screen so I can write on the screen again. All right, so back over here. Let's see, change our color. I'm going to go with the red this time. What do you notice about the angle theta? So on our screen right now, I know that angle theta was 55 degrees. And the measure of the acute angle, so acute, I know that means I have to be less than 90 degrees. The acute angle formed by the terminal side of the supplemental. So my supplemental angle is this red angle over here. Thing. So if I drop a line straight down to find my reference angle, hopefully you can see that this triangle right here is perfectly congruent and symmetrical to the purple triangle back in the first quadrant. So if I'm looking for the angle formed by the terminal side and the x-axis, that would be this angle right here. And remember that that angle is called a reference angle. And because those two triangles are congruent, hopefully you can see that the reference angle in our picture here is equal to angle theta. And that should be really obvious to us because if my supplemental angle is 180 minus theta, well then if I go on to, if I want to add some angle to that, so if you think about this, I'm here, that's my angle. If I want to add something to it, that makes the full semicircle, that makes a straight line, it makes 180 degrees. Well, what could I add to this thing right here? What can I add to that to get 180? Well, if I have 180 minus theta, if I just add theta to it, my two thetas cancel out, and I get 180 equals 180. So what do you notice about angle theta and the measure of the acute angle formed by the terminal side and the x-axis? They're both equal. The reference angle is equal to the original angle theta. All right, so we're going to move on now to example 1 in our lesson. So example 1 says, what are the sines and the cosines of an angle 2 pi over 3? You can see the angle 2 pi over 3 in our picture. Let's go in and edit this. Remember, we always start our angles from the positive x-axis, and we move in a counterclockwise direction to show our angle. So they put 2 pi over 3 up here on the unit circle, but realize that this angle in here is also 2 pi over 3. So if you want to find the sine and the cosine of your angle, what you need to do first is take a line, drop it straight down to your x-axis so that you form this triangle here. And remember that this side is y, this side is x, and we're going to need to find our reference angle for this triangle here. So I'm going to draw my triangle over here just so I can make it a little bit bigger. This is y, this is x, this is 1 because it's on the unit circle, so the radius has to be 1. And if you think about a straight line in terms of radians, that means we're using pi, then hopefully you remember that starting here, we're at 0. Up here, we're at pi over 2. Over here, we're at pi. Down here, we're at 3 pi over 2. And then back to the starting point, we're at 2 pi. So my angle of 2 pi over 3, what would I need to add to that to end up with just pi? Well, I have 2/3 of pi. Hopefully you can remember your fractions. These are really simple fractions. So hopefully you can remember that 2/3 plus 1/3 is going to give you a whole. So this reference angle in here is pi over 3. And hopefully you can also remember our conversion factors from the previous lesson. If you have pi over 3 and you want to convert it to degrees, you need to multiply by 180 over pi. And our pi's are going to cancel, and 180 divided by 3 is 60 degrees. So a pi over 3 angle is actually just a 60-degree angle. So I'm going to take this pi over 3 out and think about it as if it's a 60-degree angle instead. So now that you see that that's 60, and we always have a right angle, this should stick out to you as a 30, 60, 90, which means, again, that it's going to have the relationship of whatever this is, x. The hypotenuse will always be twice that, and the other leg will always be that number times the square root of 3. So if you compare what we have in our yellow triangle to what we have in our blue triangle, there's only one pair of sides where we have a value and an expression, and that would be the hypotenuse. So my hypotenuse from the first triangle in yellow is 1, and on the blue triangle, it's 2x. So to solve for x, I'm going to get 1/2. So this side down here is a length of 1/2. And then what we need to do is solve for y. We know that y is equal to x times the square root of 3. So that's going to give us 1/2 times the square root of 3, or just square root of 3 over 2. So this y side has a length of square root of 3 over 2. So at this point, you have the value of your x and your y on both sides of the triangle, but you don't know the SIGN sign, whether it's positive or negative for any of them. So you have to use a little bit of common sense now. If you think back to our picture on the axes, the x, y axis over on the far right, you can see that our triangle is in quadrant 2. And anytime you're in quadrant 2, your x values are negative, and your y values are positive. And this is for quadrant 2. So when I got 1/2, I should have actually put negative 1/2. And my y value is positive, it makes it stay positive. So once you have the values on your triangle, now we can answer the questions, what's the sine and what's the cosine for this angle? So the sine of 2 pi over 3 is just the y value. That's what we talked about in the warm-up. That's going to be square root of 3 over 2. The cosine of 2 pi over 3 is negative 1/2 because it's the x value. Remember, sine is y, cosine is x. So that's, it says part A, but I'm pretty sure that that's just the whole thing. Very simple one. Let's check my next picture. No, we actually do have a second part. So here's part B. Part B, what are the sine and the cosine of a negative 45-degree angle? Okay, so again, this time our angle, remember we have to start at the positive x-axis, and we're moving down this time because we're moving in a negative direction, and we have that as our terminal side. So we're going to need to draw a line from the terminal side back to the x-axis to make the triangle. And I'm going to draw my triangle again over here. This is awesome for us because they tell us it's negative 45 degrees. So I know that from here I have 45 degrees. This is 90, which makes this 45 degrees also. And this should stick out to you as one of our special triangles. We did a 30, 60, 90 in part A. Now we're doing a 45, 45, 90. So we want to find the sine and the cosine. Remember that your hypotenuse is 1, that this is your y value, this is your x value. And because we're in quadrant 4, realize that our x values are always going to be positive and our y values are going to be negative. So I'm going to draw another 45, 45, 90 triangle with my relationships on it that I know. This side is x, this side is x, this is x times the square root of 2. So just like we did in part A, we're going to take our sides that we know, the hypotenuse, x squared times the square root of 2 is equal to 1. We're going to solve for x. That gives me 1 over the square root of 2. And now you're going to learn about something called rationalize the denominator. And rationalizing the denominator means that you are going to remove all square roots from the denominator. It's okay to have a square root in the numerator, but you don't want to leave a square root in the denominator. So in order to do that, we're going to multiply this fraction by the square root of 2 over the square root of 2. And when I do that in my denominator, when I have root 2 times root 2, I get the square root of 4. And on the top, 1 times the square root of 2 is just the square root of 2. And you know that the square root of 2 in the denominator, the square root of 4, sorry, is the number 2. So this is the relationship that we want to go with. So this side up here is equal to the square root of 2 over 2. And this side, the size of it is square root of 2 over 2. But again, remember, because it's the y value, it's going to be negative for our answer. So the sine of negative 45 degrees, remember that's going to be our y value. That's negative root 2 over 2. And the cosine of negative 45 degrees is equal to our x value, which is root 2 over 2. And that's our answers for part B of example 1. Okay, moving on now to example 2. Example 2, we're going to talk about something called the Pythagorean identity. And the Pythagorean identity that we're looking at is sine squared of theta plus the cosine squared of theta is equal to 1. And this is actually written in a way that you're not used to seeing. Because what this means is that you have the sine of your angle, whatever that is, you're going to square it. And whatever the cosine of your angle is, you're going to square that. And when you do that, you'll always end up with 1. And I know these two things, the location of the square is different in both of these equations, but they mean the exact same thing. So our question says, what is the sine of theta if the cosine of theta is negative 3 over 5 and the angle with measure theta is in quadrant 3? So I think probably what we should do first is draw a set of axes. We're going to put an angle somewhere down here in quadrant 3. And let me just draw this in a different color. So I started somewhere over here, and maybe I went around like that. I'm going to draw a line back to my x-axis to create my triangle. So this is my triangle in here. And then I'm just going to draw that out on the side. This is theta in here. Theta is always going to be the thing that's between the terminal side and then the x-axis. This is the terminal side down here. This is the, oh, you can't even see what I'm doing because I'm in color. This is my terminal side. This is my x-axis, so that has to be what theta is. Okay, so they tell us cosine of this angle is -3/5. Back in the warm-up, we talked about cosine of an angle being the x value over the radius when the radius is 1. But nowhere in this question do they tell us that we're on a unit circle. So when they don't tell you that you have to be on a unit circle, what you can do is treat the relationship that you're given, the -3/5, as x being -3 and the radius being 5. So you can put a 5 down here and a -3 here, and then you just have to solve for the y value. And you can do that using the Pythagorean theorem. Another way you can think about this, if you are on the unit circle, is that the x value is -3/5 and the radius is 1. Because these two fractions right here mean the exact same thing. Okay, so we're back to our red triangle down here in this triangle. What we're going to do is our solve for y. If you know your Pythagorean, something called a Pythagorean triple, I'm not sure if I've talked about those at all this year. If you know those, you already know what the y value is, but if you don't know those, then you have to use the Pythagorean theorem. So we're going to say a squared plus b squared plus c squared. A and b, it doesn't matter which they are, but c has to be your radius. So c has to be 5. I'm just going to say a is -3 and b, I don't know. -3 squared is 9. 5 squared is 25. I need to subtract 9 from both sides, and when I do that, I get 16. So that means b has to be 4. And it could be +4, it could be -4. But when you look at the fact that we are in third quadrant, you should remember that all your x values are negative and all your y values are negative. So that means that y has to be -4. So the sign of theta is always going to be y over r, which for us is -4/5. And that's your answer. All right, moving on now to example 3. For example 3, this time we are in the unit circle, and we're looking at the tangent. So we've only done sine and cosine so far, but remember that there's 6 total trig functions. We have sine, cosine, tangent, and then the reciprocals of those, which are cosecant, secant, and cotangent. So this time we're doing a tangent. What is the tangent of -5π/6? So I'm going to draw a set of axes. Because we're in pi's, I'm going to draw my quadrant angles in terms of pi. So, and also because I'm doing negatives, instead of this being pi/2, I'm actually going to go downward. So instead of going upward, I'm going to go downwards because I have negative angles. And I'm going to call this -pi/2. This is -pi. And then this is -3π/2. And then when you get back to your starting place, then you'll be at -2π. So -5π/6. 5/6 is less than 1. So I'm not going all the way around to the negative x-axis. I'm going down here. It's more, 5/6 is more than a half, so I have to go past there. And I'm going to go maybe about there, draw a terminal side. This is my angle theta. And so what I need to do now is draw my line back up to the x-axis. So this in here, I'm going to call it theta prime. It's going to be my reference angle. Theta prime is my reference angle. And remember from the warm-up, the reference angle is going to have the same trig function values as the original angle theta. So on my triangle, I'm just going to draw it out to the side here. I know this is y, this is x, this is r, and it has to be 1 because we're on the unit circle. We know we're in third quadrant, so my x's will be negative and my y's will be positive. And now the question is, what on earth is the reference angle? What's the value of it? So if we moved 5 pi over 6 originally, and a straight line is pi, what do we need to add to 5/6 to get a whole pi? Well, 5/6 plus 1/6 of pi will give me a whole pi. So this little reference angle in here is pi over 6. And I'm just going to convert that to degrees just so that you guys can see some more practice with that. This is supposed to be a big multiplication sign. 180 over pi, the pi's cancel, 180 divided by 6 is 30. So pi over 6 is also equal to 30 degrees. We've got a right angle here, and then this should stick out to you as one of our special triangles, a 30, 60, 90. I'm just going to draw it as 30, 60, 90. This side is x, this side is 2x, this side is x times the square root of 3. So again, the relationship that we know, we have a 2x and we have a 1. So 2x is equal to 1, and x is equal to 1/2. So this side right here is 1/2, and this side right here is √3 over 2. And on our shape, let's see, we'll do neon green for our x value. This is your x, this is your x. So x has to be negative √3 over 2. And let's change to, I think it's like, sure. The y value right here is this number. Your y value is negative 1/2. So based off all that, that's great, cool. So we know that x is the cosine of our angle. We know that y is the sine of our angle. But what on earth is the tangent of our angle? You're going to have to reach back in your memory to a couple weeks ago to remember that the tangent is always the y value over the x value, or the sine value over the cosine value. So you're going to take the numbers that you've already solved for and put the y value on top, which is negative 1/2, and the x value on the bottom, which is negative √3 over 2. And then you have to simplify this fraction. So the first thing that I see is that I have a negative on the top and a negative on the bottom, so that my answer has to be positive. I also see that the denominator of each of those fractions is 2. And when your denominators match, you can cancel them out. And you'll be left with just the 1 over the square root of 3. So we need to rationalize this. And again, to rationalize, you're going to multiply by the square root of 3 over another square root of 3. And that gives you square root of 3 on top and square root of 9 on the bottom. And the square root of 9 is just the number 3. So this is our answer, which means that the tangent of negative 5 pi over 6 is √3 over 3. It's a little happy face as you solve it. And that is example 3. That's only part A. I'm going to jump over to part B for example 3. We're going to pretty much do the same type of thing here, but this time we have a different angle. We have the tangent of 3 pi. again here. I'm going to draw a set of axes. This is 0. This time we have a positive angle. So instead of going down, we're not going to go down. We're going to go up. So we have pi over 2, pi, 3 pi over 2, 2 pi. Ooh, but our angle is even bigger than that. So we went more than a full circle. So 3 pi, you should be able to see, is 2 pi plus 1 pi. So it's like, let me change this to 2. So it's like we made a full circle and then we went another pi. So essentially what we have, our angle, is a straight line in the end. So you haven't dealt with, clearly this isn't the triangle. You haven't seen one of these kind of angles before. But the way you want to do this is remember that the tangent of anything is the y value over the x value of a triangle. But there's not a triangle. So what does that mean? Well, if you are along this line right here, let's say that you're right here. Actually, let me erase that and go to the actual end of my line. Let's say that you're right here, because we're on the unit circle. And we have a radius of 1. So I'm going to be at the end. This right here is your origin. And you've moved 1 distance away. Hopefully you can see, like, let's say that you're out here. If that's 1 unit, that to go out there, that you've moved in the x direction. And because you moved left, it means that your x value is -1. So when you have, this is called a quadrantal angle. And a quadrantal angle means that your angle is sitting on one of the axes, on one of the quadrants. So you can have a quadrantal angle at pi, you can have a quadrantal angle at 0, you can have a quadrantal angle at pi over 2, and you can have a quadrantal angle at 3 pi over 2. And the thing that's interesting about quadrantal angles is that the radius is always going to equal either the x value or the y value. If you are off to the left, then the x value is going to equal the r value in terms of the magnitude. But obviously, because you move left, the x value is negative, even though the radius is positive, because you always have a distance. The radius is just the distance that you move. So the radius is 1, but the x value is, it also includes the sign, the direction. If you go to the right, then you still move in the x direction, but since you move right, your x value is positive. If you move up, then you have a positive y that you've moved, and that's going to equal the radius. And if you go straight down, then you'll have a negative y, which is equal to your radius. So our 3 pi angle is an angle where we only move to the left. Did we move up or down? No, we didn't, which means y is 0. So when you take these relationships right here and plug them in for this, the tangent of 3 pi is going to equal 0 over -1, which is just 0, and that's your answer. So the tangent of 3 pi is 0. Just as a little side note, if I had the tangent of 0 degrees or 0 radians, because they're both the same, that means we would have moved to the left. And that still would be 0. This time it would be +1, which is still 0. If I had the tangent of pi over 2, which is going up, then I move one direction up, because y is equal to r, over the x direction. I didn't move anything in the x direction, so all I did was go up. 1 divided by 0 is undefined. You can't divide by 0. And similarly, the tangent of 3 pi over 2, if you go down 1 unit, but you didn't move left or right at all, you can't divide by 0, so again, that would be undefined. So just keep those things in mind as you're going through the homework or the classwork. They'll come up at some point. That's example 3. Let's move on to example 4. Example 4 says that we have to do secant, cosecant, and cotangent for an angle. So this time we have our reciprocal function. Let's draw an axis. Let's draw 0 degrees. This is a positive measure, so I'm going to go up. Going up 90, and then we have 180, 270, and then we're back at a starting point for a full circle of 360. 135, you should be able to see somewhere over here in quadrant 2. It's actually halfway. Change colors. It's halfway between 90 and 180. So this is our angle right here. That's theta. We're going to drop it down. We're going to make a reference triangle. So my reference triangle, if this is 135, then this has to be 45. I have 45 in here, which means this has to be 45. And again, I have one of these special triangles of 45, 45, 90. Remember that our radius is 1. And if I draw a reference 45, 45, 90, I know this is x, this is x, this is x times the square root of 2. And let's take our relationship, x times the square root of 2, set it equal to 1, and solve for x. So 1 over the square root of 2. We need to rationalize that, so we're going to multiply by root 2 over root 2. And that gives me root 2 in the top and root 4 in the bottom. But we know that root 4, the square root of 4, is just the number 2. So that's this side and this side are both the square root of 2 over 2. Because we are in second quadrant, we've moved left. Our x value has to be negative, and we've moved up. Our y value has to be positive. So on our triangle, this side is negative root 2 over 2, and this side y is positive root 2 over 2. So I know the sine of 135 is going to equal x over r, which means that the cosecant of 135 is going to equal r over x. So the radius, 1 over negative root 2 over 2. Well, because these are reciprocal functions, I could write it that way, or I could just solve for the sine. And I'm going to take this arrow out. I know my x is negative root 2 over 2 divided by 1. That is not pretty looking 1. So anything over 1 is just itself. So I could take this value right here and do the reciprocal of it, and that would give me negative 2 over root 2. And in calculus, you can leave your answer this way, but in algebra 2, you need to work on, remember, rationalizing the denominator. So we're going to multiply by root 2 on the bottom, root 2 on the top. That's going to give me 2 root 2 on the top. And remember, this is root 4, but it really just simplifies to 2. The 2's cancel, and we're left with negative root 2. So my cosecant 135 is negative root 2. Let's go with actual orange. So I know that cosine, oh man, I just totally messed this up. I wonder if any of you guys caught it. Sine, I just said, was x over r. Sine's not x over r, sine's y over r. Oh man, bunch of mistakes in here. The y value is positive. So luckily, because the x and the y are the same number, they're just the sign is different. The only thing I have to do is take out the negative sign here, 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 and then it all becomes true. So the sign of 135 is positive square root of 2, not negative square root of 2. My mistake. Cosine of 135 degrees now. Now we get to x over r. So now this one is going to be negative root 2 over 2. And if you do the reciprocal, you'll have the secant of 135, which is going to be negative 2 over square root 2, which simplifies to negative square root 2. So secant 135 is negative square root 2. Finally, we're going to do, I'm doing a lot of different colors today. Let me make this one a little bit bigger point so that you'll see it. The cotangent. So I know the tangent of 135 is y over x. And because our y value and our x value are the same number, with just a different sign, when I divide them, I'm going to end up with just negative 1. If I take the reciprocal of negative 1 to get the cotangent of 135 degrees, if you take the reciprocal of 1, you just get 1 over 1, which is still 1. The sign doesn't change, so our answer is still negative 1. So cotangent 135 is negative 1. That's how you can work with all of your reciprocal functions. Okay, we've got one more example. All right, this time we're looking at example 5. Use any circle centered at the origin. I'm going to throw a grid on here this time. This says a group of rescue teams are searching a circular area in a 4-mile radius around the camp. So let me draw a set of axes. And I'm actually going to extend my y-axis stuff a little bit farther. We're going to make each block count for 1 unit. So if this is their camp right here at the center, there's 4 miles out to the left, right, 4 miles up, 4 miles left, 4 miles down. And I'm going to attempt to connect that and make a pretty circle. It's not going to be very pretty, but I'm going to try. I'm going to fix second and third quadrant. It's not perfect, but it's as good as I'm going to get from you. Okay, so there's a group of rescue teams searching a circular area in a 4-mile radius around the camp. One team travels on a path 30 degrees east of south from the camp. So I'm not sure if you guys know this. Hopefully you should. It's pretty basic. This is north. This is west. This is east. This is south. Clearly I don't know it because I mixed up east and west. I got to keep you guys on your toes today. This is east and this is west. So we're going south first, down this way first, and then we're going to move 30 degrees east of that. So you want to draw something kind of like that and show that you've moved 30 degrees, 2 degrees. What's the final position relative to their camp? So we have their camp in here, and this point down here is final position. Okay, so just like any other problem, what you want to do is draw a line back to your x-axis and create a reference triangle. On this reference triangle, we have a right angle. We need to figure out this angle in here. Since this angle down here is 30, and this shape makes a right angle, this has to be 60 in here. And if that's 60 and we have a right angle, it means down here we have a 30-degree angle, and hooray, we have another special triangle. We know that on our special triangle, this side is always x, the hypotenuse is always twice that, the y side is always x times the square root of 3. We know that because we're in the third quadrant, the net x values are going to be negative, the y values are going to be negative, the hypotenuse is always going to be positive. The hypotenuse, for us, is our 4-mile radius. So we're going to say that our hypotenuse is equal to 4, which means that x is equal to 2. And on our shape, we can see x is therefore going to be negative 2. And we can see our y value is going to be negative 2 square root 3. So the final position is a coordinate point. It's going to be negative 2, comma, negative 2 square root 3 is the final position of the resting team. Relative to the camp, which is at the origin. All right, that's example 5. We're going to look at quickly a summary of the concepts we talked about today. First, it says a reference triangle is formed using the terminal side of an angle and a perpendicular segment from the terminal point to the x-axis. This can help you find the coordinates of the terminal point of the unit circle. So we just did in example 5. Just remember that we always drew from our terminal side back to the x-axis to make your reference triangle. And hopefully you should also remember that every triangle that we looked at today was either a 30-60-90 or a 45-45-90, the two special triangles. And that's, again, that's the reason why they're called the special triangles, because they show up all the time when you're doing trig, especially when you're doing unit circles. Obviously, you can have other angles that aren't special angles, because you could have a 1 degree or a 2 degree or a 3 degree or a 20 degree or a 15 degree or anything like that. It's just that when you're doing unit circle stuff, because you're going to use the 30-60-90s and the 45-45-90s so much, it's really important that you memorize the relationships in the triangles, those two in particular, because they help you build the unit circle, and the unit circle is really important. When you take trigonometry, when you take pre-calculus and any level of calculus, whether you do calculus in high school or you take calculus in college, you're always going to come back to the trig relationships that you're learning right now. So you review it enough that eventually you guys are going to just naturally memorize it, but it's a really good idea to be intentional about trying to memorize all the trig relationships in the unit circle. And again, we're only like 3 lessons into this chapter, so there's going to be plenty more lessons that we still do with this chapter. At the bottom of the screen, you can see that we just have the trig relationships that I talked about. I think it was in example 3, with the sine being the y value, the cosine being the x, and the tangent being y over x. Also, having your reciprocal relationships, and then if you're over on the right side, if you're looking at the unit circle, y over r, x over r, y over x, similar stuff. Okay, so that is the 3rd lesson out of topic 7, trig functions and unit circle.
All right, so we have like 20 minutes left in class. You guys should go ahead and get started on the classwork. It's posted already. The independent practice is going to post soon. It hasn't posted yet though, so go ahead and start on the classwork. If you guys have any questions over the next 20 minutes, just feel free to ask in the chat, or if you want to unmute yourself and actually talk. Okay, so Susie wanted to know about how you would figure out if you have a 30, 60, 90 or a 45, 45, 90 triangle. And she gave the example of if you're trying to find the tangent of negative 4 pi over 3. So probably the first thing I would do if I have my unit circle is think about the basic unit circle has a 0 radian on the x-axis, pi over 2 on the positive y, pi at the negative x, 3 pi over 2 at the negative y, and then back here for the full circle is 2 pi. And if you are looking at the unit circle, you'll see that in the first quadrant, the first angle you get is pi over 6, then pi over 4, and then pi over 3. And then if you move around the circle, you'll see that there's always 3 sections in each of those quadrants. When you are looking at those, let me switch colors for this. The pi over 6 and the pi over 3. So the first section in the quadrant and the last section, the first and the third of those, are both going to be based off of 30, 60, 90s. So for my example, if I started from the pi over 3, if I drop this down, so this is my triangle right here. If I draw that down here separately, when I say pi over 3 on here, I'm referring to this angle theta is pi over 3. Pi over 3, if you convert it to degrees by doing 180 over pi, gives you 60 degrees, because 180 divided by 3 is 60. So this triangle is a 30, 60, 90, where the 60 degree is down here and the 30 degree is up top. If I switch to another color, if I think about the pi over 6 angle, if I drop this down and make this triangle, this theta is the pi over 6. Well, pi over 6 converted back to degrees is 30 degrees. So this is also a 30, 60, 90, where the 30 is here and the 60 is here and this is the 90. So when you're looking at the unit circle, there's always, each quadrant has 2 of the 30, 60, 90 triangles. And then that other leftover angle, the pi over 4, if I draw that one, where this is theta and that's pi over 4, pi over 4 times 180 over pi comes out to be 45 degrees. So this is your 45, 45, 90. So every triangle within any of the quadrants, well, there's going to be 2 30, 60, 90s, and there's one 45, 45, 90. So when you're thinking about the tangent of negative 4 pi over 3, basically because it's got a denominator of 3, that's kind of an indication already that it's going to be related to the pi over 3 from the first quadrant. But negative 4 pi over 3 is not in the first quadrant. So you have to figure out which quadrant it's in order to find the correct tangent. So what I would say to do is, if you look at a unit circle, you will see that pi over 3 is in first quadrant, 2 pi over 3 is in second quadrant, 3 pi over 3 is just pi because the 3 over 3 cancels. And then 4 pi over 3 is down here in third quadrant. So if 4 pi is in third quadrant, and the way you would get there is by doing that movement, then negative 4 pi over 3 would be, let's change colors to a darker purple, starting at the same location, but going the opposite direction. So negative 4 pi over 3 is actually the same thing as positive 2 pi over 3. So if you go to the pi over 3, the 2 pi over 3 angle on the unit circle, you will see that it has a the coordinates at 2 pi over 3 are negative 1/2 comma square root 3 over 2. And the tangent is just the y value divided by the x value. So that would be root 3 over 2 divided by negative 1/2. And again, the 2's cancel, and that gives you negative square root 3. That's how it's done.